Hey, I'm Joel, and I'm going to be coding up an Autograd system. So what is Autograd? Well, you may have seen my other videos where I coded a deep learning library from scratch, from NumPy. And so there what we did was we implemented layers, and then we had to manually um, implement the gradient functions and the functions for backpropagating the gradient so that we can train the models. So that's not how most modern neural net libraries work. Instead, they use something called Autograd, which is where when you do kind of arithmetic operations on the tensors, it just knows how to compute their derivatives, and you don't have to do any work to make that happen. You don't have to use their layers. You don't have to do any of that. And so, I've thought it would be fun because I have a pretty idiosyncratic notion of what counts as fun, but fun to implement that to figure out if I can make it work. So in my day job, I use a lot of PyTorch, and so I think the library that we'll end up building will look a lot like PyTorch on the surface. I don't claim that it's operating under the covers the same way PyTorch operates. I don't know how PyTorch operates under the covers. I haven't bothered to look. And it's also the case that this is the way that occurred to me to build an Autograd system. It may not be a bright way to build one. It may not be the way anyone else builds one, but it's what I thought of, and so it's what we're going to do. So I don't know exactly what I'm going to do, but I kind of have a little bit of a plan. So let's call this Autograd cd Autograd, make a Git repo, and I'm just going to make a branch for each of these videos. So let's say Git branch part 01. I can't imagine we'll have more than 99 parts for this. Object name master. Get touch readme that. Okay, I'm not as, like everyone else. I'm actually not that good at Git, so we'll see what happens. Initial readme. Okay. Now maybe it will let me do this. Okay, good. That was indeed the issue. And let me check out. And now let me start an editor. Good. So I don't need this welcome, and I have this README. So what should I type in the README? Autograd. Let's build an Autograd library. So what will our Autograd library look like? So let's make an Autograd directory, and let's give it an init.py, so it's a module. And we're going to start off by doing tensors. So let's start with a tensor module and see what goes on. So actually, before I do that, let's add at the top level let's add a requirements.txt because I know what I'm going to need. Actually, I have them already installed, but so we're going to need NumPy. That's going to be our linear algebra behind the scenes. We need pytest so we can run a unit test, and we need mypy so we can do type checking. So just all the usual stuff. So let's import NumPy as np, and we want to do a tensor class. And so what is our tensor class going to do? It's going to just wrap NumPy arrays, but it's also going to do so in a way that knows that if this tensor is the result of some sort of arithmetic operation, it knows which tensors it relies on, and it knows how to take its own gradient and push them back to gradients of the incoming. So and we're going to give it a constructor. And so data, and let's say that's a NumPy array. And, some tensors will require us to compute a gradient. So some won't. So we'll just say requires grad bool equals false. So by default, they won't require a gradient. And then it's going to need to depend on something. So we'll say depends on, and I'm going to punt for a minute about what that looks like, and just say that by default you don't depend on anything. And so what I want to do, I'll just say self.data equals data, self.requires grad equals requires grad, self.depends on equals depends on, and just to make our lives easier, I'll also say self.shape equals data.shape, so that we can just get the shape of this tensor the same way we get the shape of the underlying NumPy array. And so I punted on what this depends on looks like, but I'll call it a list of dependencies. And so to do that, say from typing import list, and also named tuple. I use named tuples everywhere, and hopefully you do too. And so I need to define a dependency type. And I'll just make it a named tuple because it won't do anything other than store a little bit of data. And so this tensor may depend what is, VS Code always uses the wrong, let's just call it Autograd. Always uses the wrong interpreter at first, and that was why it didn't like this Python 3.6 format. I should probably do something about that. So a dependency is going to depend on some other tensor. So let's say tensor, because it hasn't been defined yet. And we're also going to need some sort of gradient function. And I'm just going to use NumPy arrays and see if I can get away with that. I may have to change it later too. And that means I need callable. So what I'm saying is each dependency points back to some other tensor, and it has some function that knows how to take my gradient and turn it into a gradient for those, which is what you need for back propagation. So in some ways this is similar to when we built layers and each layer knew how to differentiate itself backwards. It's just that now we're going to build this into the kind of primitive arithmetic operations, not the layers. So you don't have to use the layers to get things done. So the idea is that, like, let's say I take two tensors and add them, then the sum, the sum of those two will be another tensor that depends on both of those two, that will kind of point back to them, and then also know when I add two tensors, if I have the gradient of some, say, loss function with respect to their sum, then here's how to turn that into a gradient with respect to each of the original inputs, and we'll have to deal with that in a little bit. So I think that this is fine, and I think that's good. Just to make it look nice, if I want to get a nice string representation of myself, I'll just say return tensor, and I use f strings because I'm a Python 3.6 person, and let's say self.data, and then I'll also say requires grad equals self.requires grad. So there's other stuff like the depends on that I'm not going to put in the string representation, but that should be good enough. So I think that's good for now. And the third thing I would like to do is I would like to define a function that sums up all the elements of a tensor. So a tensor is just an n-dimensional array. I would like to sum it up and get down to a zero-dimensional tensor. So def sum self, and that will return a tensor. And what do I want to do? In particular, I want to not implement that in this file. I am going to instead what I would really like to do actually is this will be fine. I'll call it tensor ops.py. And so this is tensor ops, and actually maybe I don't want to do this because this is going to make my life really difficult with with circular references. So I'm going to hold off on that for now, and so I'll just go back to tensor and do tensor sum of t, which is tensor, and it's going to return a zero-dimensional tensor. So takes a tensor and returns the zero tensor that's the sum of all its elements. Okay. So what do I want to do? I want to return, a tensor, obviously, that contains some data. Some requires grad, and some depends on. And now I just need to figure out what those are. Well, the data is easy, right? So data is just t.data.sum. So throughout this, we're going to be relying on NumPy for all of its arithmetic operations. We're just going to freeload off of that, but we're going to add on the layer that does the gradient. Okay, so the idea behind all of this is that if I have a tensor that requires a gradient, then everything that depends on it also requires a gradient. So if t requires a gradient, then tensor sum of t also requires a gradient. If t does not require a gradient, then tensor sum of t does not require a gradient. So that's just going to be t dot requires grad. And now if it requires a gradient, then we need to compute a dependency, right? So we'll say dependency equals dependency, and it depends on a tensor, which is obviously t, and some grad function. So we need to define a grad function. Grad function, takes a grad np.ndArray and returns an np.ndArray. That's how we define this dependency thing. Takes a gradient and outputs a gradient. So the output of this, grad is necessarily a zero tensor because the output of this is a zero tensor. So each input element contributes that much. And so what do I mean? What I mean is, let's say I have some tensor which equals 1, 1, or whatever. Let's say tensor is 5, 6, 7, 8. And then, t dot sum, that means that is going to be 5 plus 6 is 11, plus 8, plus 7 is 18, 26, whatever. And let's say, let's say t2 equals t dot sum, and that's 26 or whatever, but that's fine. And if I have some loss function, and I know that changing t2 causes some increase in the loss, then I know that changing this first element by a little bit increases t2 by that same amount, right? If I add 1 to the first element of t, I've added 1 to the sum. If I add 1 to the second element of t, I've added 1 to the sum. If I add 1 to the third element of t, I've added 1 to the sum. If I add 1 to the fourth element of the t, I add 1 to the sum. So adding 1 to any one of these elements is just adds 1 to the sum. Adding any amount to these elements adds that amount to the sum. So what that means is that the gradient of the sum just gets applied to each element. So return grad, which is a zero tensor, times np dot ones like t.data, right? So if I have a tensor and I take its sum, I do this. Dependency equals dependency t of grad function. So that should be fine. Otherwise, and I'm just going to go back and say depends on is this list. Otherwise, depends on is none. And that returns me a tensor. So now I can just say def sum of self equals return tensor sum of self. Okay? And so the one thing that we haven't done is actually implement the backward propagation of gradients. And so we can do that here too. Backward self grad, which again is going to be this is going to be a tensor, I think. And it's going to also output a tensor. Yeah, that seems right. Okay. And so what I want to do is, if self dot requires if we don't require a gradient, then I'm going to return none. Actually, you know what? I'm actually going to raise an error. That might be a bad idea. Called backward on non requires grad tensor. And actually, I'll just change that again. So I'll say assert self.requires grad called backward on non requires grad tensor. That should be fine. So now we know that we've required grad because I've done that. And what I want to do is, if I require grad, depends on, or do that so that if I get past none, I'll get an empty list. For dependency in self dot depends on. So dependency is a tensor. So what I want is dependency dot tensor dot backward. Actually, one other thing I want to do is let's store a gradient and we'll just set it to be none. And that reminds me of another thing I need to do. This is what happens when you go in without a plan. So when I have the gradient with respect to this guy, the first thing I want to do is I want to say self.grad equals, actually I want to add it because this could depend on multiple things. So self.grad plus equals grad.data. Self.grad.data. Well, what is the grad going to be? Is the grad going to be a NumPy array, or is it going to be a tensor? Let's leave it like this, and we may have to change it because I don't know if that's going to get things right. Dependency.tensor.backward. So backward. Oh, this is going to, yeah, let's leave it like this. Backwards grad equals dependency.grad function of grad.data. I don't like that we're calling grad.data all the time here, but that's all right. And then dependency tensor backwards. Okay, so for now, I'm actually just going to make this a NumPy array. I don't like that mixing of things. Yeah, we'll leave it a tensor. Okay, good. Um, but that means I gotta wrap this grad dot. Um, actually, no. Uh, and dependency tensor dot backwards. It needs a tensor, so I'll just do tensor of backwards grad. That's fine. I think that's good. The only other thing I want to do is I want to define a zero grad, which will just zero out the grad because we'll need to do that a bunch of times. And we'll just say self.grad equals tensor of np dot zeros like self.data. So the grad will look like data, except it will start off with zeros. And let's just say if self dot requires grad, self dot zero grad, else self dot grad tensor. Actually, let me just do it this way. Okay, so we've set the grad as a tensor to none. If it requires a gradient, then we zero it out. To zero it out, we set it to be a tensor of zeros that look like the data. When we do backwards, we take our self.gradient, and later I think we might be able to get rid of some of this ugliness, but for now we have to deal with this. And then for dependency and self-depends on, use that grad function that we passed in to get the gradient backwards, and now call backwards on each of the dependency tensors. So I think this looks pretty nice. MyPy, ignore missing imports. MyPy Autograd. MyPy is just my static type checker. And I have to do ignore missing imports because NumPy does not have type stubs. So incompatible types in assignment in line 19. So let's figure that out. Expression has type 30 missing return statement. So this doesn't need to return anything, I don't think. So that's fine. And 62 incompatible types in assignment. So let me just do that. And now let me run MyPy one more time. Compatible type, source and type none, variables type tensor. That's 19. So let me bring in optional. Surprised optional cares. Usually it's a little bit more understanding than that, but item none of optional tensor has okay, well, I'm not going to worry about that. I'll figure it out later. The one thing I would like to do, though, is add tests. So let's say tests test tensor sum.py. We'll see if I can write unit tests off the top of my head. Import unit tests, class test tensor sum, unit test, test case. So test simple sum self. So let's say we better do some from autograd.tensor import tensor. So what do I want to do? I want to say t1 equals tensor int. Okay, so now I want to go back and do one more thing, which is that having to pass in a numpy array is a real pain. I like to be able to pass in a list or even a float. So what I'm going to do is I'm going to define a type for things that can be converted to an array. So arrayable equals a union of float and list, and it can be a list of floats and numpy.nd array, and now I can ensure array. I have some arrayable type, and it's going to ensure that it's a numpy.nd array, which is if is instance arrayable np.nd array, and these are fine. Just return it as is. Otherwise I'll return I'll call numpy array on it, and it's got to be a list or a number, and it will do the right thing in either case. And so now I can go down here and say that data, instead of having to be a numpy array, can be an arrayable, and then self.data is just ensure array of data, and that way. So why did I do that? I did that so that I can say tensor 1, 2, 3, whereas otherwise I would have had to do a numpy array requires grad equals true, and t2 equals t1 dot sum. And now what do I want to do? So I said there's one more thing I need to do. So when we have a zero-dimensional tensor, we can call backwards without passing a gradient, and it's just implicitly 1. So if grad is none, if self.shape is empty, which is like what happens, grad equals tensor 1, which should be fine. Else, raise runtime error. Grad must be specified for non-zero tensor. So I think that should be fine. And so now what I can do is I can do t2 dot backward. And if that's the case, t1 dot grad should not be none. So let's just even see if that happens. Let's see if pytest even works. 1 errors. No module named Autograd. Okay, so nope. Okay, so here's where you discover that I am really terrible at all this stuff. Let me move tests up to the top level and see if that works, because that might work. No module named Autograd. Seriously? All right. Could this be just from not having an init.py here? Probably not. I can't imagine that that's and remove pycache. All right, here's where you can see that I have no idea what I'm doing. List object has no attribute shape. Okay, good. We're getting closer now. And now the problem is that self.shape equals self.data.shape because I passed in a list. I only did self.data is that. So now that should be okay. Let's try pytest one more time. And it passed. Okay, great. So now we can actually write the real test, which is what should t1.grad be? T1.grad should be, and let me remind myself, I said T1, I said gradients are going to be tensors. Is that right? That's right. So t1.grad.data.toList, and that's a NumPy function. And I think that should be 1, 1, 1, because like I said, an increase in any of these results in the corresponding increase in the sum. Calling it with nothing, implicitly uses 1, so that's what it should be. So now let's try pytest one more time. And it still passed. Now what def tests sum with grad. So one more I will do is say, what if I called backwards with, let's say 3, and then this should be 3, 3, 3. Those both pass. Okay, so I think that's all the tests that I want to write for this section. And so the idea here being that if I have, again, some loss function, and I know that increasing the sum by a small amount increases the loss by 3 times that amount, which is what the gradient being 3 means, then the same is true for each of those inputs to the sum, because increasing the input by a small amount increases the sum by that exact same amount, which increases the loss function by 3 times that amount. So the gradient should just get spread across each of those. So I think that's actually pretty good. So what's get status? Get add readme.t, get add autograd, init.py, get add autograd tensor. I hate these pycache files. Get add tests, get status. Nano.get ignore pycache, get status, get rm tests pycache. Again, you can see how bad I am at all this Git stuff. Get status. So we've got README, we've got init tensor, init test tensor sum, and I'm just going to get add requirements. That's important. Again, nano.get ignore, and I'm just going to add cache. Hopefully I don't call anything cache. Why is that my PyCache and PyTest cache VS Code? Get, I don't want VS Code either. Okay, let's add .get ignore and get commit -m. Let's call that part 1. And I think that's all I would like to do for right now. So I am going to stop recording. So thank you for bearing with me. Thank you for watching. I hope that was interesting. Probably not the parts with me making a fool of myself, not knowing how to use Git and PyTest, but hopefully the rest of it was somewhat interesting. This is like really boring groundwork, and I think future parts might be more interesting if you're into this kind of stuff. Otherwise, if this wasn't interesting, then probably the future parts won't be that interesting. But yeah, thanks. Thank you for watching.